So today our main focus is going to be fractions. With fractions, there are so many different things that you can do. Fractions typically represent a part of a whole. So you can talk about eating a pizza, and if you have 1 out of the 4 pieces of pizza, this 1/4 is a fraction. You can also talk about things like 2/5 of your land has trees, or 2/3 of the cars on the road are red. You can talk about 1/10 of the water in a pond has algae. You can talk about fractions in a number of different ways, and there are different ways to represent fractions. You can do fractions out of 5s, out of 3s, out of 10s, out of pretty much any number. You can do a fraction out of 2, out of 3, out of 4, out of 5, out of basically any number up to any number you can possibly think of. There's so many different ways to represent fractions. And then we can also talk about mixed numbers, which are, let's say I ate 4 slices of the one pizza and 1 slice of the other pizza. So I had 1 whole pizza and then 1/4 of a pizza. Or we can talk about improper fractions, where I had 5 pieces of pizza out of the 4 slices per pizza, and this translates to each other by doing a little property where we multiply the base and add the top. We multiply the denominator and add the numerator. So 1 times 4 is 4, plus 1 is 5, and we keep our denominator the same. So there's a bunch of different things that we can do with fractions. Let's say we wanted to say we had 1 and 1/2. So we would multiply the bottom, add the top. 2 times 1 is 2, plus 1 is 3. So our mixed number would be 1/2, and our improper fraction would be 3/2. And it's only improper because technically there's not supposed to be a bigger number on the top. So when we want to make it a mixed number, when we want to reverse the process, we can say 3 divided by 2, and our top number always goes inside, even if it's bigger. And we want to say, how many times does 2 go into 3? It goes in once. We get 2, and we subtract to give us 1. Now, when we were younger, we always learned the remainder of 1 trick, where if we had 1 left over, we would just call it remainder of 1. But if we wanted to put it into a fraction, we're actually going to take this answer as our whole number, our remainder as our numerator, and our dividend as our denominator. So we're going to end up using 1 and 1/2, and that is going to be our mixed number rather than an improper fraction. So we can flip back and forth like that. So let's say we had 2 and 3/4. We would want to multiply the top, that is 8, and then add 3, that is 11/4. And then if we wanted to undo it to check, we would simply put our division sign. Our top number goes inside and our bottom number goes outside. I like to think of this as a cowboy, and he is riding his horse, and our little division sign is actually the cowboy's house. And so the cowboy goes inside and the horse stays outside, hitched to, let's just call it a pole. And so that is my reference. That is what I learned when I was a child, and it has stuck with me ever since. It is a cowboy riding a horse, and the cowboy goes inside and the horse stays outside. So 4 goes into 11. Let's see, 4, 8, 12. So 12 doesn't work, so 8 does. So that is 4 times 2 is 8. And then we have to subtract. We get 11 minus 8 is 3. And so we have 2 and 3/4. 2 and 3/4. fourths. Our answer, the amount of times 4 goes into 11, is our whole number. The remainder is our 3, is our numerator. And the thing that we divided by in the first place, our dividend, is our denominator. So that is how we change from mixed to improper and back. If we wanted to look at changing it to a decimal, however, let's take 1/2. We would have to, again, put the top number inside, the bottom number outside, and 2 does not go into 1 evenly. So we give it a decimal and a 0. We put a decimal up at the top. Now, 2 does go into 10, and it goes in 5 times. Now, 5 times 2 is 10, and when we get a 0 as our answer, this is our finished product. So 1/2 equals 0.5. And this is our fraction. This is our decimal. Okay, so if we wanted to say something like 1/3, we would make our house, our 1 goes inside, our 3 goes outside. 3 doesn't go into 1, so we add a decimal and a 0. 3 goes into 10 3 times. 3 times 3 is 9. If we subtract and get 1. Now, this is where we start to notice patterns in decimals. So here we have a 1 and here we have a 1. And if we said 3 doesn't go into 1, let's add a 0. We gave it another 3, and then we get another 9, and we subtract and get another 1. We're coming up with this pattern where no matter how many times I put 3 into 10, I'm going to get 3. I'm going to times it and get 9. I'm going to subtract it and get 1. I'm going to bring down a 0. I'm going to put 3 into 10. I'm going to give it a 3, multiply to get 9, subtract it to get a 1. So we're coming up with this pattern of 3s that are happening over and over again. So when we start noticing that there's a pattern of 3s, we can say that 1/3 is equal to 0.3 repeating. And all we have to do is put the number that is repeating with a line over it. So let's say we had something like 0.25 where the 2 and the 5 were repeating. So we would have 0.25, and how this would look if we went on with our division would be 2, 5, 2, 5, 2, 5, and it would never ever stop. But if we had something like 2, 5 with only the 5 repeating, it would look something like 2, 5, 5, 5, 5, where the 5 never stops. In this case, only the 3 will continue on forever. Okay, so that is how we want to address repeating decimals. And so the question then comes to, how do we get a decimal back into a fraction? And this is where learning place values is very important. So let's say we have 0.123. Our 0.1 is in our tenths place. Our 0.12, the 2, is in our hundredths place. And our 3 in 0.123 is in our thousandths place. And so here, when we talk about 0.1, we're talking about 0.1 tenths, or 1/10, or 1/10. Okay, if we talked about 0.2, we're saying 0.2 2/10, 2/10, which of course can be reduced, and we'll talk about that in a moment. If we were talking about 0.12, that we are looking at the last digit. We are calling that 12 hundredths, and we are going to put 12/100, and that can reduce. Okay, so how do we reduce? So I say 2/10. Both of those things are even, which is a nice place to start. We can say that 2 goes into 2 once, and 10 goes into 2 5 times. 1 divided by 5 is our reduced form of 2/10. So if we were looking at 0.2, 1/5 would be our equivalent fraction. And then of course we can check it by putting a division symbol, putting our 1 inside, our 5 outside. 5 doesn't go into 1, so we put a decimal and a 0, making it a 10. 5 does go into 10 twice. 2 times 5 is 10, and we come up with a 0. So 1/5 is equal to 0.2. 0.2 is equal to 1/5. And that is how decimals to fractions work. So if we wanted to take another quick example at that, let's take 0.25. Okay, now 0.25, this is in my hundredths place. So we can say 25 over 100. Now, both of these are not divisible by 2, but there is something in common with them. If you can divide them both by 5, then that is something you can work with. 25 divided by 5, well, that's 5. And 100 divided by 5, that is 20. And then, oh, we can notice that it is also divisible by 5. Again, that is 1 out of 4. Now, if you see 25 over 100 and you think, hey, that's 1/4, then that's your answer right there. 1/4. You say, this is $1, this is 25 cents, that's 1/4. That makes total sense to me. Or, if you notice that both of these are divisible by 25, 25 goes into 25 once, 25 goes into 104 times, there's your answer. But there's nothing wrong with taking it step by step. There's nothing wrong with saying, that's definitely divisible by 5, that's definitely divisible by 5. So if you have something, say 22 over 100, 22 over 100 is divisible by 2, that's 11 over 50. Now this is the only one that ended up working just because it's just the example I came up with. But if there were something more in common, you could definitely take it step by step, divided by 2, divided by 2, divided by 2. Okay, you could say 0.50, and you could say 50 over 100 because the 0 is in the hundredths place. And then you could say, oh, 50 is divisible by 2, 100 is divisible by 2, that's 25 over 50. Those are both divisible by 5, that's 5 over 10, and those are both divisible by 5, that is 1 over 2. That is 1/2. And generally, if you see 0.5, you know that that is going to be 1/2 anyways. And if you were asked to give the biggest number that goes into each, you just take the numbers that you divided by and you multiply those. 2 times 5 is 10. 10 times 5 is 50. So if we wanted to backtrack and say 50 divided by 100 and divide each of those by 50, 50 goes into 50 once, 50 goes into 100 twice. So that is our final answer, and it is the same process with 1 step as it is 3 steps. This might just save you a little bit of time if you can visualize it right away. Okay, the harder part about dealing with fractions is turning a repeating decimal into a fraction. And when they teach this in, say, middle school, what they say is, let's give 0.3 repeating the value of x. Okay, and let's say we want the 3 to be out in front, so we want to move this over to look like 3.3 repeating. And the reason we're having this on the side is because we want to know that it is a decimal and that is a 3 repeating. But if we did this, that means we multiplied by 10. So this is saying that this is 10x because it is 10 of these individual x's. So now we can say, well, I do not want my 0.3 repeating, so that means I do not want that last x. So if I said 10x minus x, that is 9. And if I got rid of the 0.3 repeating, I am just left with 3. And please don't forget that x like I just did. And then we can say that this is divisible by 9. We want to get rid of that 9 because all we care about is 1x. Now my x equals 3 over 9, which can be reduced by dividing by 3 to 1/3. Now how I like to explain it is that if I have one number that is being repeated, all I'm going to do is take away my decimal, take away my repeated sign, and put it over that many 9s. And then, of course, reduce as you normally should. 3 divided by 3 is 1, 9 divided by 3 is 3. And it is nice to see this, but it is also nice to see a shortcut. So let's say I had 0.25 repeating. Okay, I want to get rid of the decimal, I want to get rid of the repeating sign, and I want to put it over this many digits of 9. So I have 25 over 99. And to prove it to you, we're going to give this the value of x. We're going to move this over twice, which is the same as multiplying by 100. So here we have 100x equals 25.25 repeating. I do not want my 25 repeating, so I'm going to get rid of it, but then I also have to get rid of the x that it is paired with. So 100 minus 1 is 99, and do not forget your x. And if I minus this 25 repeating, I am left with 25. Now to get rid of this 99, all I do is divide by it, and I am left with 25 over 99. And you can try, but probably there's nothing going to go into this like it does here. 1, but that doesn't change the division. Neither of them are even. This is divisible by 3, but 25 is not. So we can generally assume that there's nothing going to be divisible by it from single digits. So now that we have a basic understanding of how fractions work, we are going to be looking at some operations with fractions. So let's say I had 1/2 plus 1/3. Now, the most difficult thing about adding and subtracting with fractions is that these two denominators have to be the same. And the easiest way to do that, the simplest and most effective, quick way to just find your common denominator is to multiply by the opposite denominators. Okay, so 3 times 2 is 6, but you also have to do it to the top. 3 times 1 is 3, plus 2 times 3 is 6, and you do it to the top. 2 times 1 is 2. Now, all we have to do is add the tops together. We leave the bottoms the same. This is like saying I had 3/6 of a pizza and you had 2/6 of a pizza. We didn't combinedly have 5/12. We had 5/6 of that pizza. Okay, so the other example is, let's say that I had 1/2 of the pizza, you had 1/4 of the pizza. And we just like to use pizza because it is a nice representation of what we're talking about here. Now, instead of multiplying by 4 and then multiplying by 2, you may be able to see that 2 already can go into 4. And if that's something that can happen, then you can say 2 goes into 4 twice. We need to multiply 2 by 2 to get us to our 4. So 2 times 1 is 2, 2 times 2 is 4, plus our 1/4, and this does not need to change because our goal is to get to 4. 2 plus 1 is 3, and 4 plus 4, and the 4s stay. We do not need to change the 4s. We are not having 3/8 of pizza, we're just having 3/4. Okay, so that is how we go about doing that. Okay, so it's the same process, let's say, if I were going to be subtracting. If I said 1/3 minus 1/2, we want these two denominators to be the same. So we can multiply by 2, multiply by 2, 2 over 6 minus 2, times 3, minus 3 over 6, so 2 minus 3 is 1, and we keep our 6 the same. Okay, and that is going to be the same if we do 1/2 minus 1/4. This goes into 4, so we just need to multiply by 2. 2 times 1 is 2. 2 times 2 is 4, minus 1 over 4. 2 minus 1 is 1, and we keep our 4. Find a page here. Okay. Now, the other two operations, multiplication and division, are pretty simple when it comes to fractions. Let's say we have 1/2 times 1/3. All we do is multiply straight across the top and then straight across the bottom. 1 times 1 is 1. 2 times 3 is 6, and that is our answer. Okay, so let's do another one. If we had 1/2 times 1/4, we would have 1 times 1 is 1, 2 times 4 is 8, and that would be our answer. It's very, very simple. It's not complicated at all. You just have to remember the top and the bottom, which is a little different compared to our addition and subtraction, which we did not use the bottom as an adding or subtracting piece. Here, though, we do. The last piece is division, which is something that can be really exciting and fun if you are teaching that, because we use the acronym keep, change, flip. But we do want to emphasize this fact that we are not taking shortcuts and learning KFC or KCF. We are actually multiplying the reciprocal. So we need to understand that the reciprocal means that this flips and that we are multiplying that reciprocal. So 1 times 3 is 3, and 2 times 1 is 2, and this gives us a improper fraction. So if we would like, we could go ahead and divide in order to find that this is 1 and 1/2. It depends on exactly what is being asked, if it is asking for a simplified fraction or if it is just asking for a normal given answer. Okay, so let's try another one of those. Let's do 1/2, divided by 1/4. We're going to keep this, and we are going to make a reciprocal and multiply it, or keep, change, flip. We like to let the students know that we are doing a proper mathematical thing here, but also giving them an acronym helps them remember for the long run. A lot of times multiplying the reciprocal can be something that they'll forget easily, but if we give them something cute and fun, they will remember it for the long haul. So then we do 1 times 4 is 4, 2 times 1 is 2. Now you can reduce that, and actually you can say 4 divided by 2. How many times does 2 go into 4? And that is a solid whole number answer, which is 2. Now I want to show you something else. If we have these cross products that go into each other, say if 4 and 2 were already a fraction and you wanted to make it smaller but keep it a fraction, you could divide both of them by 2. That gives you 2, that gives you 1 if we keep it in a fraction. And now you can replace that 4 with what it became, a 2, and you can replace that 2 with what it became, a 1, and you can simply say 2 and 1, 2 and 1, and then reducing that 2 over 1, anything over 1 is the top number, which is 2. And this is a bit of a complicated situation. This is called cross-simplifying, and if you are not comfortable with it right away, definitely don't worry about it. It is just something that is nice to see and nice to use when you come across things that are way higher numbers, like maybe 50 and 100, and you can see that 50 goes into 100 twice. But when it comes to things like 2, 4, 3, and 6, it's not something that really needs to be done. It can just be a little bit of a time saver if you understand the concepts. Okay? So that is going to be the end of our fraction video. So we talked about changing a decimal to a fraction and doing that back. We talked about changing improper to a mixed number and changing that back. We talked about repeating decimals as a fraction, which is something that may need a lot of practice and is actually very cool once you get used to it. We talked about adding and subtracting fractions, and we talked about multiplying and dividing fractions.